And we will start with an important topic called host defenses. Right? I wanted to cover this last time, but because epidemiology is such an important chapter, I'm going slightly slower than the other ones. By host defenses, all of you know, this is the defenses that we have against any bacteria, any virus, or any other organism which causes disease. And this is especially important keeping in mind the present pandemic. Okay, all of us know that we have got various types of immunity, and one is adaptive and one is innate. Innate is something which is within us. Adaptive is something which is natural, which comes from our mothers or from infection. And artificial is what we are most worried about in today's pandemic times. That is the vaccine. Either it is an active immunization or a passive immunization. This is a revision from what you have learned before in your previous MBBS, but please remember that we are talking about a very, very important topic today, which is immunity. Okay, at birth, we have got a natural immunity, which is a passive immunity. It comes from mother to us. Maternal antibodies are gradually lost over a period of 6 months. Many remain free of infections for 3 months or more. So a baby can rarely be infected unless you are not looking after him or her in the first 3 months of life. There is something what we call as a biological shield due to immunoglobulin M and IgG, which comes from the cord blood and the plasma. That's why many of you may have read about cord blood preservation. Many people go to banks and preserve the cord blood for their children because in future it may be of some importance. Breast milk and fetal hemoglobin also gives us transient protection. Okay, so innate versus adaptive immunity. The innate immunity is, within hours we get a response, and it is not variable. There are limited number of specificities, and it's constant during response to any antigen. Whereas adaptive immunity takes some days or weeks to develop. It is of variable nature. It may be of different nature in me and different nature in you. And it improves during the response. So don't worry about this. But this is the differences between the innate and the adaptive immunity. The common effector mechanisms are there in both for destruction of pathogens. Now, there are various lines of defense. Like we have our defenses against China, Pakistan, and other enemies all around us. We have got our body's defense against various antigens or various organisms which cause problems. First line of defense is physical and chemical barriers like the skin, the tear, the saliva, the earwax, and the mucus. Okay, the second line of defense includes the WBCs, the complement system, which you have read in detail and know perhaps much more than what I know, and an inflammatory response. The third line of defense is specific defense, which includes lymphocytes and antibodies. First and second line of defense are commonly called as non-specific defense mechanisms. Now, this is again a repeat, which is taken from the internet. It says non-specific and specific. We all see that non-specific are first and second line, whereas here also we have mentioned first and second line as non-specific, and the same thing has been elaborated. So we are more interested in specific defenses. Okay, and what are specific defenses? Specific defenses come into play once microorganisms have breached local defense mechanisms. It's to recognize, destroy, and eliminate the antigenic material. Now, a person is said to be immune, like we often use this word, when he or she possesses specific protective antibodies or cellular immunity as a result of previous infection, or is so conditioned by such previous experience as to respond adequately to prevent infection. So either we are vaccinated, either we have got the antibodies because we are conditioned by a previous experience or by vaccines. Even the infections that we get are a kind of vaccination. What we give by vaccination is to introduce a minor harmless infection, actually. okay, which is followed by clinical illness of a mild nature, or in case you are unlucky, you have a clinical illness of full-fledged nature, sorry, and that gives us immunity. So I'll repeat, a person is said to be immune when he or she possesses specific protective antibodies or cellular immunity. Two things, antibodies or cellular immunity, which can be because of vaccination or a previous infection. Okay, so these we have already shown you in the chart, this chart. It can be either because of a natural infection which happens to us, or an artificial infection which is given by passive or active means. I hope all of you are getting as to where I am arriving, the all important part of the chapter on vaccination. Now, there are two types of immunity, active and passive. I need not tell you all these things, you all know. And in active immunity, we have got humoral, cellular, and combined. Whereas in passive immunity, we have got normal human immunoglobulin, specific human immunoglobulin, and antitoxins or anti-sera. Ladies and gentlemen, this is a very, very important slide. Get your concepts clear. When you write about host defenses, when you write about specific host defenses, when you write about immunity, please mention this algorithm. Please mention this table, which says there are two types of artificial adaptive immunity. Okay, artificial adaptive immunity, artificial adaptive immunity. So we are here. We are concerned about this. I have talked about natural immunity from the mother to the child in the first slide. I have also not talked so much about infection, but we all know what is infection. Now, active immunity. It is as a result of specific or immunization or infection. Okay, very simple. It is because of immunization associated with presence of antibodies, which is humoral immunity, or cells, which is cellular immunity, or there can be a combination. It is specific for a particular disease, and there is a period for which you are protected. You can't say that I get infection from flu, I got infected with flu, that I'll be having a lifelong immunity. Certain things you get lifelong immunity, perhaps chickenpox, but then not in every disease. Now, acquiring active immunity, there are various ways which you can acquire, and I have already told you these things in the previous classes: clinical, subclinical infections, and of course in this class we are going to talk about immunization with a killed vaccine, live vaccine, or a toxoid. Please pay attention when we come to immunity especially. The immune response can be of two types, primary and secondary. When an antigen is administered for the first time to an animal or a human who has no previous exposure, we get a primary response. Now, if I am or you are to get a COVID vaccine, you will get a primary response because it is being administered to you for the first time. Antibodies appear after 3 to 10 days, not immediately. That's why there was a table between innate and adaptive immunity. IgM is the first antibody to appear. It rises for 2 to 3 days or more, reaches a peak, and declines. If the antigenic stimulus is sufficient, which is ensured in a vaccination, then we get IgG, which reaches a peak in 7 to 10 days. It starts a little later and it stays for a long time and falls over a period of few weeks or months or sometimes a few years. Now, this is going to be clear in the next diagram, which says that the moment we have a primary response, there is an IgM which rises rapidly, plateaus and falls. Whereas the late response is IgG, which starts a little later but stays for a longer time and gives you protection for long. Factors influencing the primary response are dose, nature, route of administration of antigen, the adjuvants. I'm going to describe adjuvants a little later. Presence of maternal antibodies, how strong I am from my mother. That's why mother's health is so important. Presence of maternal antibodies, natural nutritional status of host. How well do I eat? Is my diet balanced? That's why your parents tell you to eat healthy. Genetic and coexisting diseases. Small doses induce IgM, and to elicit IgG, we require 50 times the dose of IgM. That's why I said here, if the dose is sufficient, so it should be 50 times the dose of what is required to elicit an IgM response. So you must know this. This is a very important chart. It is given a diagram. It is given in your book. Draw this when you get a question. Now, what is the outcome? Education of reticuloendothelial system. We all know this. Production of memory cells or prime cells by both B and T. And these cells are responsible for an immunological memory in your body. That's why that word or that phrase is marked in red. Please remember, all of us have an immunological memory because our reticuloendothelial system has been primed, educated, and we have got memory cells or prime cells in us which have been produced by both types of lymphocytes. So that is the primary response. What is the secondary or the booster response? Subsequent exposure to same antigen displays a faster and more intense antibody response. If I get a COVID vaccine today and I have had a primary response, after that, after a few years or after a few months, if the COVID virus, it comes to me, I will have a stronger response from my body because I already have the vaccine in me. I'm already primed. My cells are already primed. I have got immunological memory, okay, which I told you here. Now, it also involves production of IgM and IgG. It's not that the IgM and IgG bodies are totally forgotten, but what is more important is memory cells. I talked about memory here, memory cells or prime cells. So therefore, increased antibody response is due to existence of memory cells. Once you have a primary response of memory cells in you, they stay in your body and they are the soldiers who prevent Pakistan or China into coming in and attacking you. There is a brief IgM and much larger IgG response. I've already told you this. So it differs from primary response because this has got a shorter latent period, the secondary response. Antibody production is more rapid. Antibodies are more, remember, much more abundant. Antibody produced have greater avidity or capacity to bind to antigen and eliminate it. Antibody response maintained at high levels for a longer period of time. So therefore, all of us require a secondary response. Those of you who have taken hepatitis B vaccine would remember that they have taken 3 doses initially and then they have taken a booster. Why is a booster required? Because you want to improve the production of antibodies, make it quicker, and you want to make it in large numbers so that they are retained in your body and your immunological memory is boosted. This is the immune response which all of you have studied in your PATH lessons. Open your PATH book sometimes. Robbins is a wonderful book and you must read about immunity in detail because whether you do SPM or medicine or pediatrics, whatever you do in life, you will have to talk about immunity. You have to remember about immunization and vaccination. So these are the various types of responses. I won't spend my time because I've already told you what is the primary response and what is the secondary response, okay? The primary response and the secondary response and how during the secondary response, the antibodies are much more in number. So we come down to the types of immunity which are active and passive. Most of you know about these things. It's just a revision. Therefore, I can afford to go a little faster. The humoral immunity comes from B cells. Why is it called B? Because it is bone marrow derived, which proliferate and produce specific antibody after antigen presentation by macrophages. So therefore, there is a specific antibody in your body because of the response of B cells, which is called as humoral immunity. It is just a revision. And how I remember the 5 types of immunoglobulins are by the mnemonic GAMDE, GAMDE. Okay, G, IgG, IgA, IgM, IgD, and IgE. Antibodies act directly, neutralizing microbes. They directly attack the enemy and they neutralize it, or they neutralize the toxins, or they render the microbes susceptible to attack by polymorphonucleosides, leukocytes, and monocytes. So there are 3 ways in which the immunoglobulins help you. One is directly attacking, that is the infantry, which goes in front and fights the war. One is by neutralizing toxins. Perhaps, we can talk about cyber warfare and what goes on in the cloud. How can we neutralize their machines or their nuclear weapons? And we also can think about microbes being made weaker and susceptible to attack by our leukocytes and monocytes. So there are three methods of neutralizing the microbes by humoral immunity. Therefore, we have a complement system and antibodies which causes efficient phagocytosis of the disease-causing organism. All these things you must just recollect or go back to your books and read. Antibodies are specific, that is, react with same antigen which provoked their production. Due to specificity, the host response is limited. One antibody reacts with one antigenically related group. Remember this. I cannot vaccinate myself for BCG and claim that I have got protection against COVID, like many people are doing. But still, remember, the host response is specific. This has been a formidable problem. That's why there's a problem in production of vaccines, because there are various types and subtypes of a virus. The example given in your book is numerous antigenic types of rhinoviruses which prevent production of a single vaccine for all types. Therefore, if you have a specific vaccine for flu, you don't have the vaccine, that vaccine will not act against the other virus which causes different type of flu. And we know that there are so many types of flus. Similarly, there are so many types of rhinoviruses. Even I was reading about COVID virus, the SARS-CoV-2. There are various subtypes, 5 subtypes. Okay, the present one which is going on is A2 in India. There has been O, A1, and all these things. So we have got no specific, vaccine for. We cannot claim a vaccine for COVID SARS-CoV-2. We have to have a specific vaccine for the antigen. And by the time you prepare a specific vaccine for that particular type of antigen or subtype, it again mutates. So viruses are very clever. We think that we humans are clever. They are cleverer. So therefore, these we can skip. We know that I've already told you how the host response is there. It neutralizes microbes, neutralizes toxins, and renders microbes susceptible to attack by polymorphonuclear leukocytes and phagocytes. So these are the various protective mechanism of the humoral immunity. Same thing, okay? It's just in a diagrammatic format. Complement fixation, precipitation of soluble antigens, agglutination, neutralization, all these things you know from your previous MBBS. So one is humoral, the other one is cellular. Cellular components of immunity are the thymus-derived or T cells. That was B, this is T, are key cellular components of immunity. T cells have an antigenic receptor that recognizes and reacts to a specific antigen. So all these T cells have a receptor. There are various types of T cells: cytotoxic, helper, delayed hypersensitivity, and suppressor cells. And they are known by a capital letter T with a small letter following it, namely TC, TH, TD, and TS. So these are the various types of T cells. We are talking about cellular immunity. Antibodies combat most infections, but not all. Remember, humoral immunity is good for you, but it is not super good. It is not going to help you for all infections. Some escape bacterial action of leukocyte, bactericidal action of leukocyte. Example, Mycobacterium tuberculosis, leprae, Candida albicans, Salmonella typhi. They even multiply in the macrophages. Okay, so these are very, very clever bacteria and organisms. They escape or they have learned to combat the humoral mechanisms. Macrophages can be stimulated by lymphokines secreted by the T cells. Activated macrophages are more efficient in phagocytosis. So now we come to the T cells. What is the action the T cells do? And the first action which we have discussed is that the macrophages are stimulated by the lymphokines which are products of T cells. And therefore they become activated macrophages. Something like you wearing one mask and then wearing one more mask on top. So you have got activated mask. You are now giving yourself double protection. We have got the BSF in the front line, the Border Security Force. Then we have the ITBP, the Indo-Tibetan Border Police. And then we have the army. So we have got various layers of defense in our country. I talked about the first, second, and third line of defense. Similarly, we have got various mechanisms to tackle the antigen. And one of them is by making our BSF stronger or the border people stronger by giving them better arms, better ammunition. Okay, we read all these in the papers. Similarly, macrophages are activated. I'm just giving you an example. Thus, T cells they differentiate into subpopulations and help B cells. Thus, T cells are the helper people for the B cells. They activate the macrophages, which are now stimulated by lymphokines to act on the bacteria which have escaped them. They do not secrete antibodies. Please remember, antibodies are secreted in humoral immunity by the B cells. They do not secrete antibodies, but initiate chain of responses. That's why it is marked in red when in contact with antigen. And one we have already discussed is the activated macrophage. So that's why I have not made this bold, macrophage activation. What are the other methods by which the T cells act? Release of cytotoxic factors, mononuclear inflammatory reactions, delayed hypersensitivity, secretion of immunological mediators, example, interferon. All these things are taught to you in detail in pathology. So please remember your pathology lessons. You cannot afford to forget what you've learned in your previous MBBS, and you must revise them sometimes. That's why keep your books and go back and revise the role of cellular immunity in detail to get your fundas a little more clearer. Now, what is the importance of cellular immunity? It plays a fundamental role in resisting infection. A child born, please mark this sentence. A child born with deficiency of humoral antibody production can survive up to 6 years without replacement therapy. But severe defect in cell-mediated immunity or cellular immunity, the child will die within the first 6 months. So now, friends, you know what is more important between the two. If you are given a choice to choose between cellular and humoral, which one will you choose? Responsible for immunity against tuberculosis, brucellosis, etc. I just mentioned here that the tuberculosis, the leprae, the candidas, and the typhus, they escape the humoral antibodies or the humoral immunity, and therefore we have the cellular immunity coming into play. Your body has got so many defenses against these people, and therefore we come down to the third, which is a combination. B and T lymphocytes cooperate with each other and other accessory cells like the macrophages and human killer cells, and their joint factions constitute complex events of immunity. So your concepts are now clear. You've got active and passive immunity. Okay, we have talked about the primary and the secondary response. In active immunity, we are talking about the humoral and the cellular immunity and how both cooperate with each other to produce what is called as a solid, as a very, very powerful defense system in your body. Since none of you have been affected by the present pandemic, you are all very, very immune and very strong. But please continue doing your exercises, following a healthy diet, and your regular breathing exercises and the other things that you are doing. Some people are drinking Ayurvedic kada also. To be effective, vaccines must elicit both humoral and cell-mediated responses. So now I have made you understand that why both are important, and to have an ideal vaccine. You are reading so much about a COVID vaccine nowadays, the Oxford, the Indian ones. Okay, so they have to elicit both a humoral and cell-mediated response against this very, very clever virus, the COVID virus. Okay, that is when the vaccine will become effective. Today's paper says the Russian President Putin has said that he is commissioning a vaccine so soon. Many people have criticized it. It may not be a very effective vaccine. This is the difference between humoral and cell-mediated response. I've already told you both. Basically, B cell deals with antibodies. See, it gives rise to antibodies, whereas the T cells, the various types, they help the B cell, they stimulate the B cells, they stimulate cytotoxic cells, and they also stimulate the memory B cells and the memory T cells. All these things are not taught in detail in SPM, but what you must remember is that they activate macrophages, they release cytotoxic factors, they have mononuclear inflammatory reactions, delayed hypersensitivity, and secretion of immunological mediators like interferon. That is more important. Helper T cells required for optimal production of antibodies. Suppressor T cells inhibit IgG synthesis. These are the various roles of cells. You need not worry so much about these ones. K cells, NK cells, vaccines should elicit both types of responses. This is most important. Why is active immunity superior to passive immunity? We have not yet gone to passive, but I'll tell you why it is more superior, the active. The duration of protection, like that of natural infection, is frequently long. That's why we go for vaccines. Severe reactions are rare. Protective efficacy is much higher, less expensive. Vaccines are cheaper than anti-sera. Those of you who had the misfortune of having had a bad dog bite will have remembered that they were vaccinated after the dog bite, as well as around the bite site they have given you immunoglobulins. The policy has changed now. We have talked about rabies in your communicable disease classes. So you go back and see how in that disease we give both. But remember, what my point was here is that the anti-rabies vaccine is much cheaper to produce than the human immunoglobulin which is given to you. Human immunoglobulin costs a few thousands. It can make you poorer, whereas the vaccine costs a few hundreds. So that's why vaccines are cheaper. So they are much, much superior or better than passive immunity giving agents. Immune response can be overwhelmed beyond a certain threshold at which resistance fades. This is also very important to realize. We all are immunized from our childhood. We all are getting immunity through natural infections every day in our lives. Yet, sometimes we fall ill. Why? Because of the heavy dosage of the antigen, because we are all different. I am tall, dark, you are shorter, fairer, somebody is stronger, I am weaker. So, individual variations, his or her physiological state, almost the same thing, and the microorganism in question. Some microorganisms, like the present virus, the coronavirus, is very, very clever. Hence, in spite of vaccination, individuals contract a disease. You may be asked in the exam, in spite of your vaccination, why do you get a disease? You have to say it is because of the heavy dosage of the microorganism, of the individual variations and our different physiological states, and that the microorganism itself is a very, very clever one which can mutate, change, and have its own ways of resisting your immunity. Some factors responsible for maintenance of immunity. Please remember, in these times, don't get fatigued. Have healthy surroundings all around you. Have a good balanced diet. Don't take too many drugs, because sometimes some drugs have side effects and they neutralize the effect of the vaccine. And be in a very, very strong and healthy mental state. Please remember, more than your physical fitness perhaps, this mental state is very important in such times, because all of us are now locked down. We have not gone out of our houses, and many of us are feeling the brunt. We want to go out. We want to make that mistake, right? But please remember, you have to have a very, very strong mental state to boost up your immunity. Okay, if we come down to passive immunity, antibodies produced in one body are transferred to another to induce protection. It is something like your body has antibodies and you are giving it to me to make me, to protect me. It is something like the plasma therapy many people are talking about. People who have been affected by COVID, they have got their antibodies in the plasma. That's why they are being requested, they are being worshipped, they are being prayed to. Please donate your plasma. My father is not well, my mother is not well, I am not well, and they are taking money for it. Okay, so these are ready-made antibodies. It may be induced by administration of an antibody that is an immunoglobulin. I just talked about the rabies immunoglobulin. Transfer of maternal antibody, which I've already told you, through placenta or the breast milk, and by transfer of lymphocytes to induce passive cellular immunity, which is still in its experimental stage. So therefore, the only option which is left with us at this adult stage of our lives is administration of an antibody, because long ago our maternal antibodies are gone. This is still experimental. So in effect, only administration of an antibody is left for passive immunity. How passive immunity differs from active. Immunity is rapidly established. You want to have a shortcut, please immediately give something so that the chap is okay. Immunity produced is only temporary till the antibody is eliminated. There is no education of the reticoendothelial system, which is very, very important. I told you how the cellular and the humoral immunity, they do it. Useful for an individual who cannot form antibodies or takes time to develop. Many of us have immune deficiency states, or we are immune compromised. Okay, this is a very, very important term. You've heard about it so many times in present pandemic times. Herd immunity. It is also called as community immunity. When vaccination of a portion of the population provides protection to the unprotected. We have got 150 people in your class. We vaccinate about 120. The other 30 people are not vaccinated. But remember, these 120 people getting vaccinated become a herd, and they produce herd immunity, which makes it difficult for the communicable disease to maintain a chain of infection. I talked about the dynamics of disease transmission last time, and the other 30 who have not been vaccinated, they are protected. This is the this is the idea behind pulse polio. This is the idea behind herd immunity, a word which is being talked about so much in today's times. Okay? So therefore, once we have epidemics of a disease, like we used to have epidemics of plague once upon a time when India was poor in ancient times, we used to call it Mahamari. All these epidemics have built up herd immunity in us, and therefore nowadays you hear very, very rarely of one odd plague cases somewhere. Okay? So please remember, herd immunity may come as a short note in the exam. It is an immunological barrier to spread the disease in the herd. Most importantly, you have to remember this: when vaccination of a portion of the population automatically provides protection to the portion which is not vaccinated. Now, herd structure includes hosts, alternative animal hosts, insects, all around, things all around you, environmental and social factors, all these things are important. So you cannot say that herd immunity can develop in an environment which is unhealthy. Well, 100% vaccination is not possible and not necessary. We can always develop herd immunity. How much less from the 100% is the crucial question. And this is determined by various serological surveys. Many people say that when 60 to 70% of the population is infected by COVID, automatically the rest 30 to 40% will be protected. So all these things have to be worked out. Okay? Elements which contribute to herd immunity: occurrence of clinical infection in the herd, immunization. Obviously, this should have been the number one point. Immunization, occurrence of clinical and subclinical infection, the herd structure, which is never constant. Some people are coming, some people are migrating. Ongoing immunization program. That is why I talked about pulse polio. It's a very, very important program which has affected the elimination of polio from our country. So these are the 4 important factors which are elements which contribute to herd immunity. There is something called as herd immunity threshold, proportion of immune individuals in a population above which a disease may no longer exist. Now, we are looking for a immunity threshold in case of COVID. Some scientists are saying 60, some are saying 70, some are saying 68. So where is this threshold? Herd immunity threshold. It varies with virulence of the disease, efficacy of the vaccine, and the contact parameter of the population. So obviously it depends on the agent, it depends on the vaccine, and it depends on how well the population has been immunized through an ongoing immunization program. It is just a repeat. So we will quickly follow what is called as immunizing agents. I've got about 10 minutes. I started 10 minutes late, so please bear with me. Artificial immunity can be given by three things: vaccines, immunoglobulins, antisera. Remember, immunizing agents is part of a long question. Many a time when immunizing agents come, people write only about some vaccines. They don't write about immunoglobulins and the antisera. So there are three agents which can give us artificial immunity. And the first one is vaccines. Vaccines are immunobiological substances designed to produce specific protection against a given disease. They stimulate the production of protective antibodies or other immune mechanisms. Remember this definition and learn it. They can be, this is Edward Jenner, who's giving the smallpox vaccine in 1798. Remember, about 220 years ago. There are various milestones in vaccination which are given in your book, starting from 1798 smallpox till even after 76 also we have got so many vaccines which has come up. Live vaccines, there are various types of vaccines. One is live, prepared from live or wild, generally attenuated organisms. What is attenuation? It is making the thing harmless. The vaccine is live, but it cannot harm you. It is passed repeatedly in tissue cultures or chick embryos, and it loses its capacity to induce a full-blown disease, but it retains its immunogenicity. Please remember, friends, what is the meaning of the word attenuated? You will use this word very often in your lives. Live attenuated vaccine. They are more potent than kill vaccines. They multiply in the host and result in more or a larger antigenic dose, have all the major and minor components. They engage certain tissues of the body, like the intestine by the polio vaccine. The polio vaccine lodges itself in the intestine and gets excreted. Other mechanisms are like the persistence of a latent virus in your body. So live vaccines, most important, most useful. There are various examples of live vaccines, and all of you know these examples: bacterial, viral, and rickettsial. BCG, oral typhoid, plague, viral, oral polio, yellow fever, measles, rubella, mumps. Please remember some examples and give them in your answers. There should be certain precautions while administering live vaccines. Should not be administered in immune deficiency states, or mostly they say don't administer in pregnancy. That's why in pregnancy we give a toxoid. If you remember, tetanus, toxoid. So now the things are becoming easier for you. When two live vaccines are required, they are given simultaneously at different sites, this hand and this deltoid, or they are given at an interval of at least 3 weeks. Proper storage has to be there to retain effectiveness. We will deal more on this a little later when I talked about a vaccine vial monitor, maybe in the next class. And single dose generally gives you protection, but now we are also giving booster doses, like in case of MR vaccine, or we are giving booster in hepatitis B. Okay, so therefore additional doses are required for seroconversion. Measles and polio are exceptions of single doses. Durable immunity is not always as long as that of natural infection. Doesn't matter, but you require a vaccine. In inactivated or killed vaccine, organisms grown in culture media, then inactivated by heat or chemicals. They're usually safe, more stable, though less efficacious. I've given you the example of rabies vaccine. Primary series of 2 to 3 doses, booster is required, usually subcutaneous or intramuscular route. Contraindication is severe local or generalized reactions to a previous dose. This is how a primary vaccination gives you a response, and how a booster dose enhances the IgG response. Please remember, these are the killed vaccines, bacterial and viral. There are various examples given in your book. There is also a table which differentiates between a live and a killed vaccine. Please go through it. I have already repeated them in the course of my lecture. I don't want to repeat it. I just want to give you the rest. Toxoids, protein vaccines, recombinant protein vaccines, polysaccharide-based vaccines, and conjugated vaccines are the third type after live, killed, there are subunit vaccines in which toxoids come. Toxoids, they are exotoxins produced by, say, tetanus or diphtheria. The toxins produced by these organisms are detoxicated and used in preparation of vaccines. The antibodies neutralize the toxic moiety during infection. They are highly efficacious and safe. I have given you the examples. Protein vaccines, they are single protein, a combination of proteins from a pathogen. The examples are acellular pertussis vaccine. Okay, please remember the headings. First one was toxoid, next one is protein vaccine, also the influenza vaccine. Then we have recombinant protein vaccines. Recombinant technology is used to make possible expression of protective protein antigens in heterologous expression systems. Please remember, it's a technique, and therefore we have more efficient vaccine in a recombinant DNA technology. The drawbacks are there is reduced immunogenicity and hence an adjuvant may be needed. I'll tell you what is adjuvant. Polysaccharide based vaccines are stimulation of antibody response to surface polysaccharide. And that's a strategy to develop vaccines against encapsulated bacteria. Please remember, polysaccharide based vaccines, the capsule in the surface that is used. Okay? Immune response is often very, very specific. The examples are given. And finally, we have conjugated vaccines. These are chemically linked to a protein. Polysaccharides are chemically linked to a protein that the T cells recognize. Don't have to go into depths. Just remember that there are various types of subunit vaccines. When the question comes about immunizing agents, write about vaccines, immunoglobulins, and the antisera. When you talk about only live vaccine, when you talk about only vaccines, talk about live, killed, and subunit. In subunit vaccines, there are 5 types. And of course, we have got combinations in which we have got a mixed vaccine or a combined vaccine. Some well-known combinations you all know. I will not repeat it. DPT, MMR, hepatitis A and B and all these things, pentavalent vaccine and all these things. Other components in vaccines are what I am going to tell you now because I used a word called adjuvant. Adjuvants are substances that are added to vaccines with the intent of potentiating the immune response so that greater amount of antibody is produced. So remember, they are potentiators. And what are the examples? Aluminium phosphate, aluminum hydroxide, potassium, aluminum sulfate, oil in water, liposomes. They are adjuvants. They are added to the vaccines to make it much more powerful. That's all in adjuvant. May come as a short note. Okay? What they do is they produce a local granuloma which retains the antigen and from which the antigen is slowly released. So therefore, once the antigen is released in your body slowly, it gives you an antibody response. Okay, so adjuvants are very, very important. Antibiotics are sometimes added to vaccines to prevent bacterial contamination. Preservatives like thimerosal or formaldehyde is added. They inactivate viruses, detoxify bacterial toxins, prevent serious secondary infections. We have got stabilizers which are added to vaccines. They confirm product quality and stability, control the acidity or the pH, stabilize antigens, prevent antigens from adhering to the glass vials. Most of the vaccines are in glass vials. So the antigens may adhere there. So what do you do to prevent that is by adding stabilizers like salts, lactose, human serum albumin, gelatin, bovine serum albumin. Okay? So remember, these are the various things that are added to vaccines. Adjuvants are the most important ones. I talked about adjuvants initially, and therefore I said the other components in vaccines, also known as excipients, are the various adjuvants, the antibiotics, the preservatives, and the stabilizers. There are various future prospects. There is no end to it. I wish some of you take up vaccine research and you go on to do some research. Immunoglobulins, I've already told you, they give you passive immunization. There are 5 types. Gamma-8, you need not go into much of details. There are normal human immunoglobulin preparations and specific or hyperimmune immunoglobulin preparations. The specific are the costlier, and we are more using them like in hepatitis B, rabies, and tetanus. They are generally IM and IV. I've already told you the doses are larger and they are divided into various sites. That's why I said those of you who have had a bad dog bite, please revise your lessons in rabies, and therefore you will connect. Finally, we have got the antisera, serum containing antibodies obtained from animal. They're used for passive immunization. Okay, human immunoglobulin preparations exist, but they are very small in number. Prepared from non-human sources against tetanus, diphtheria, botulism, gas gangrene, snake bite. That's why you have heard about ASV, anti-snake venom. Okay, they are basically serum containing antibodies. Those of you who watch the Animal Planet and the Discovery Channel, you will see how the snakes, a poison is taken out and they are then neutralized, and the antibodies are derived from that serum to make it an anti-snake venom. In case of snake bite, those are given. Occasionally, these may give rise to anaphylactic shock and serum sickness. Therefore, one has to take care. But snake bite doesn't give you time. So you got to do no sensitivity test and administer an anti-snake venom in case of a poisonous snake bite. So that completes the lesson, the chapter, the part on vaccines. Very, very important. Thank you for your time. I hope I have not overshot because the next speaker must be waiting. All the best. Protect yourself. Take care. And like I say every time, go back and revise your chapter. Just mark it with some pen or highlighter or with a pencil so that you can easily understand it during your exam revisions. Thank you.